Time is something we live in, like fish live in water. It flows around us, carries us forward, and shapes every second of our existence. But what if we could escape it? What if we could bend time to our will, move backward to the past, or leap forward into the future? It sounds like science fiction, something from movies and novels. But time travel, believe it or not, is not entirely impossible. In fact, science says it's already happening, right now. Let's start with a strange but true fact. Time is not absolute. This was one of the most radical conclusions of Albert Einstein's theory of relativity. According to special relativity, the faster you move through space, the slower you move through time. This has been proven with extreme precision. Astronauts aboard the International Space Station experience time slightly slower than people on Earth. The difference is tiny, just fractions of a second, but it's real. And it's measurable. This phenomenon is called time dilation. Imagine two twins. One stays on Earth, the other boards a spaceship and travels near the speed of light. When the traveling twin returns, they will have aged less than their sibling. This isn't a thought experiment. It's known as the twin paradox, and it's supported by hard physics. In essence, fast motion equals slow time. This is one form of time travel into the future. Gravity also affects time. General relativity tells us that massive objects like planets or black holes warp the fabric of space-time. The closer you are to a massive object, the slower time passes for you relative to someone farther away. We've seen this in action too. GPS satellites orbiting far above Earth experience time slightly faster than we do on the ground. Their clocks have to be constantly adjusted to stay in sync with our own. If we didn't, GPS would become inaccurate in just minutes. These two principles, motion and gravity, form the foundation of real-world time travel. We've learned how to manipulate time by going faster or getting closer to massive objects. But these effects are small. What about traveling decades, centuries, or even millennia into the future? Theoretically, it's possible. If we could build a spaceship that travels at 99.99% the speed of light, time on board would slow dramatically. A journey that feels like a few years to the crew could correspond to hundreds or thousands of years passing on Earth. When they return, the planet would be radically different. Everyone they knew would be gone. They would have, in a sense, leapt into the future. This is not a violation of any law of physics. It's simply a consequence of how space-time behaves at extreme speeds. But going backward in time is a different story. It introduces paradoxes. If you go back and prevent your grandparents from meeting, do you cease to exist? This is the famous grandfather paradox, and it's a major headache for physicists. It suggests that backward time travel might be logically impossible. Still, some solutions have been proposed. One idea is the concept of closed time-like curves, paths in space-time that loop back on themselves. These are allowed in certain solutions to Einstein's equations, such as the rotating universe model proposed by Kurt Gödel. In theory, such a loop could allow you to revisit the past. But creating or accessing one would require conditions or materials that may not exist, like negative energy or exotic matter. Another theoretical model is the wormhole. A wormhole is a tunnel through space-time, connecting two distant points. If one mouth of the wormhole is accelerated near light speed and then returned, time would pass differently at each end. Stepping into one end could allow you to emerge from the other at an earlier time. Again, the problem is stability. Wormholes, if they exist, would collapse instantly without something to hold them open, something like negative energy, which remains purely hypothetical. Quantum physics adds even more layers. At the smallest scales, particles behave unpredictably. Some interpretations of quantum mechanics, like the many worlds theory, suggest that every possible outcome of every event actually happens in separate, branching universes. In this framework, going back in time and changing something wouldn't alter your original timeline. It would create a new one. There are no paradoxes, just parallel histories. Could we harness this? Could we find a way to move between timelines or travel along a single one without contradiction? These are open questions, and while no one has built a time machine, the rules of the universe don't clearly forbid it. Theoretical physicist Kip Thorne has explored these ideas deeply, even advising on the film Interstellar, which portrayed time dilation around a black hole with surprising scientific accuracy. So where does that leave us? We've already traveled into the future by tiny fractions of a second. We know how to do more, in theory, if we could build the technology. Going backward remains speculative but not ruled out. Time travel, then, isn't a fantasy. It's a frontier, a domain where physics, philosophy, and imagination collide. And in the next chapter, we'll dive deeper into the engineering challenges, the cosmic dangers, and the wildest ideas humanity has ever had for escaping the grip of time itself. To move from theory to practice, we must confront the immense engineering challenges that time travel presents. It's not just about abstract equations, it's about matter, energy, and the limits of technology. Let's start with the most realistic method: forward time travel through velocity. To achieve the kind of time dilation needed to leap into the future significantly, we'd need to approach the speed of light, nearly 300,000 kilometers per second. The fastest spacecraft ever built, NASA's Parker Solar Probe, travels at about 0.064% the speed of light. To reach 99.999%, we'd need an entirely new class of propulsion, far beyond rockets or ion drives. One theoretical option is the antimatter engine. Antimatter and matter annihilate on contact, releasing pure energy via Einstein's equation E8mc2. A single gram of antimatter could yield the energy of a nuclear bomb. If harnessed, this could drive a ship fast enough for significant time dilation. But producing and storing antimatter is currently beyond our reach. The total amount of antimatter ever created by humans is less than a milligram, and keeping it stable is incredibly dangerous. Another concept is the fusion rocket, using nuclear fusion reactions like those that power the sun to generate propulsion. Projects like NASA's proposed Bussard ramjet envision collecting hydrogen from space to fuel a continuous fusion engine. But we haven't even achieved stable fusion on Earth. We're still decades away from this becoming viable for propulsion, let alone interstellar travel. There's also the theoretical warp drive, inspired by general relativity. Miguel Alcubierre proposed a solution in 1994 that involves compressing space in front of a spacecraft and expanding it behind, allowing faster-than-light travel without breaking the cosmic speed limit. It works on paper, but it requires negative energy, an exotic form of matter with less than zero energy density. We have no evidence that such matter exists or could be produced in usable quantities. Now let's talk about the idea of traveling into the past. The most promising candidate is the wormhole. A wormhole could, in theory, connect 2 points in space and time, allowing for instant travel between them. If one end of the wormhole is accelerated to near light speed and then brought back due to time dilation, it would become younger than the other end. Step through the older end and you emerge in the past. It sounds elegant, but stabilizing a wormhole poses enormous problems. Physicists speculate that a substance called exotic matter could hold a wormhole open. Exotic matter would have negative mass and pressure, traits not observed in any natural material. Even if it exists, we'd need it in vast amounts. Without it, the wormhole collapses faster than light can pass through. In short, it's like trying to keep a tunnel open in the middle of a landslide. Beyond exotic materials, there's the issue of causality. What happens if you go back and change something crucial, like saving a life that was meant to be lost? This leads to paradoxes that break the logical fabric of reality. Physicists have proposed mechanisms to avoid this. One is the Novikov self-consistency principle, which states that events in a time loop are always consistent. No matter what you do, you can't change the past in a way that creates a contradiction. You could go back in time, but everything you do must already be part of history. Alternatively, the many worlds interpretation says that each decision or change branches into a new universe. Kill your grandfather in the past and you don't erase yourself. You just create a new timeline where you never existed. The original universe continues unaffected. This avoids paradoxes but raises unsettling questions. Would that other you still be you, or just a copy? These ideas aren't just fantasy. They're actively debated in the highest levels of physics. Theoretical models by physicists like Kip Thorne and Igor Novikov provide mathematical frameworks for time machines, using concepts like rotating black holes or cosmic strings, infinitely long, incredibly dense defects in space-time that might bend it into loops. Again, all speculative but not forbidden. Let's explore the darker side. If time travel were possible, it could be catastrophically dangerous. A person from the future might disrupt history. A virus could be brought into the past, causing a pandemic. Knowledge of future technologies or events could collapse economies or trigger wars. And who controls access to time travel? A government? A corporation? A dictator? The ethical and existential risks are enormous. To prevent such dangers, some theories suggest the universe may have built-in protections. Stephen Hawking proposed the chronology protection conjecture, the idea that natural laws prevent time travel to the past. According to this, quantum effects would destabilize any wormhole or time machine before it could be used. If true, it would mean that the universe self-corrects to prevent paradoxes. It would explain why we've never seen time travelers, despite all our curiosity. But what if they're here and we just don't know it? Some fringe thinkers suggest that UFO sightings or unexplained phenomena could be visits from future humans. Others speculate that our universe is a kind of simulation, where time travel is just a feature turned off by the system's designers. These are wild ideas, but they speak to a deep human need. To control time, to rewrite regrets, to relive moments, to know what's coming. Time travel captures our imagination because it confronts the deepest aspects of our existence: mortality, causality, destiny. It's not just about machines or black holes. It's about meaning. Every second we experience is irreversible. Every decision is final. The desire to break that rule is universal. And yet, maybe time doesn't need to be broken. Maybe understanding it is enough. In the next chapter, we'll explore how time might not be what we think it is at all, how quantum mechanics, entropy, and consciousness could reshape everything we know about past, present, and future. We tend to think of time as a straight arrow, moving forward, ticking uniformly, never stopping. But this perception might be an illusion. Physics, especially at the quantum level, paints a very different picture. In the equations that govern the universe, Newton's laws, Einstein's field equations, the Schrödinger equation, there's no inherent direction to time. The math works just as well whether time moves forward or backward. So why do we only experience time going one way? The answer may lie in entropy. According to the second law of thermodynamics, the total entropy of a closed system always increases. Entropy is a measure of disorder. Over time, systems move from order to chaos, from hot to cold, from structure to decay. Ice melts. Stars burn out. Buildings crumble. Entropy gives time its direction, its arrow. In a universe with increasing entropy, the past is a state of lower disorder, and the future is a state of higher disorder. This is why you remember the past but not the future. Memory itself may be a product of entropy. Your brain stores ordered information about what has happened. But the future hasn't happened yet. It's a sea of uncertainty. If somehow we could reverse entropy, could we reverse time itself? Some physicists speculate this might be possible in extreme conditions, like near a black hole or at the birth of the universe. But on human scales, reversing entropy is virtually impossible. Then there's the quantum world, a realm where particles can exist in multiple states at once and cause and effect become fuzzy. In quantum entanglement, two particles can influence each other instantly across vast distances. It seems to defy time altogether. In experiments, changes made to one particle appear to affect the other, even if they're separated by space, and possibly even time. This suggests that at a fundamental level, time may not be linear at all. One interpretation of quantum mechanics, the transactional interpretation, even proposes that particles send waves both forward and backward in time, and that interactions occur when these waves meet across the timeline. This idea is not mainstream, but it shows how unsettled our understanding of time truly is. We don't fully know what time is, we only experience its effects. Now let's bring consciousness into the equation. Our experience of time is deeply tied to how our brains perceive it. Time slows down during moments of trauma or danger. It speeds up when we're focused or engaged. A minute can feel like an hour, or an hour like a minute. Neuroscientists have found that our brains construct time from sensory input, memory, and attention. In dreams, we can experience hours in just minutes of real time. This suggests that time, at least as we perceive it, is not fixed. It's subjective. What if time travel doesn't mean physically moving through space-time, but mentally? Some theories suggest that consciousness might be able to transcend time, especially in altered states like meditation, psychedelics, or near-death experiences. There are anecdotal reports of people seeing the future, reliving the past, or experiencing all of time at once. While these are not scientifically proven, they hint at a connection between mind and time that remains poorly understood. In fact, there's a growing school of thought that time itself is emergent, not fundamental. According to researchers like Carlo Rovelli, time may arise from relationships between events rather than existing on its own. In loop quantum gravity, space-time is not a smooth continuum, but a network of tiny loops. Time, in this view, is not a background against which things happen. It's a product of change itself. Some physicists go further. Julian Barber proposes that all moments in time exist simultaneously, like frames of a film. We don't move through time. Instead, our consciousness jumps from one frame to another, creating the illusion of motion. In this timeless universe, every possible configuration of the cosmos exists eternally. There is no past or future, only a vast landscape of nows. If true, this would redefine what it means to travel in time. We wouldn't need machines or energy. We'd need a way to navigate this landscape, like flipping pages in a cosmic book. Some have speculated that this could be done with advanced forms of consciousness or with a yet undiscovered aspect of physics. Could time travel then be less about technology and more about perception? Could civilizations far more advanced than ours have discovered how to access other moments through mental or informational means? This might explain why we don't see obvious time travelers. They wouldn't need machines. They'd simply tune into a different point in the temporal fabric. This brings us to one of the most provocative possibilities, that time is not something we move through, but something we create. Just as space can be warped by mass, time might be shaped by observation, intention, or information. Some scientists have explored the idea that information is the true foundation of the universe, that everything, including time and space, emerges from quantum bits, or qubits. In this view, changing information patterns could alter time itself. It's a radical idea, but it aligns with the strange, almost dreamlike nature of time we observe in quantum physics. And it suggests that time travel may not require breaking the laws of nature, only understanding them more deeply. So where does this leave us? Time travel as a physical phenomenon may be limited by energy, technology, and paradox. But time travel as a conceptual quantum or conscious phenomenon might be far more accessible and far stranger. In our final chapter, we'll explore what time travel means for humanity, ethically, philosophically, and spiritually. Because whether or not we ever build a time machine, the desire to travel through time reveals something profound about who we are. Time travel is more than a scientific puzzle. It's a mirror reflecting our deepest desires, to undo mistakes, to relive joy, to glimpse the future. Whether it's possible with machines, with consciousness, or only through imagination, our obsession with time reveals a fundamental truth. We are creatures aware of our mortality, desperately trying to outpace it. Perhaps the most powerful form of time travel isn't moving through time, but understanding it. Savoring the present, learning from the past, shaping the future. The real mystery isn't whether time travel is possible, it's why we yearn for it in the first place. Because in the end, time doesn't just pass. It reveals